06. Project Time Management. In this question, we're going to be talking about an arrow diagram. We shall see shortly what this diagram represents. Looking at the arrow diagram, for the sake of shortening the length of time that the whole project would take, some of the work from group A to E would have to be shortened by 1 day each. So the question is, which of the following combinations shows the route that shortens the whole project by 2 days? In other words, which of the processes should be shortened in order to shorten the entire project by 2 days? Now the numbers in this diagram represent the days that it takes. Option A says A, C and E. You can see them here. Option B says A and D. Option C says B, C and E. And option D says B and D. In order to understand the question properly, we should see how we can draw up an arrow diagram from a table of the required works, the time that each work takes to carry out, and any kind of requirements of previous works to carry out a work. So the arrow diagram will be constructed using this information in the table below, and that's the table. Based on the above table, the arrow diagram for this question can be constructed. For the purpose of explanation, the connection points will be circles in the arrow diagrams, will be labelled with the Greek alphabet alpha to epsilon. Just a reminder that the Greek alphabet is alpha, beta, gamma, delta and epsilon. They're analogous to A, B, C, D and E. So they will be ordered like this. And for the sake of making explanation more comprehensive, the time required, although there is no unit given in the table, we will first of all say that they are hours. It's just easier to understand if we say that there are hours, even though in the question we are not given a context of any time. Now, let's quickly have a look first of all at some of the points in this table. If you look at works A and B, we'll quickly notice that they have no preparatory requirements. In other words, they'll be a great place to start building our arrow diagrams. So if we say that the first point that we have is the first circle, then we can have one process which will be the work A, and another process which will be the work B. And it will carry on like this, and you'll have some more points along this table. And you can see that C depends on B, so you may have a C stemming from another point here, and D depending on A and C, so we can carry out like this. But we can see that A and B would be a good place to start because they have no preparations required. Just to be clear, preparatory work refers to the work that must be finished and completed before a particular work can be carried out. We saw that the work C had a preparatory requirement on B, which means that C cannot be processed until B has been completed, and it must be completed. If B takes 4 units of time, we're going to be saying hours. If we say that B takes 4 hours to complete, then C cannot happen until those 4 hours have been completely carried out. From connection point alpha, we'll be labeling the first point alpha. Work A and B can start at the same time. We discussed this before because they both have no preparations required. For work D, if we refer to the table, for work D, the preparatory work would be A and C, which takes 7 hours and 4 hours to complete respectively. Since preparatory work must be completed before one can move to the next stage, even if one is to start simultaneously at connection point alpha and beta, you can see alpha and beta here, the earliest one could do to initiate and start on work D would be 7 hours later. So just the earliest one could do would be 7 hours later. The reason is that to start work D, you must have both A and C. So the key word is and. You have to have both A and C. Which means that even though after 4 hours C is complete, A is only complete after 7 hours, so D can only begin after 7 hours. For work F, the preparatory work would be A, C, and E, which takes 7 hours, 4 hours, and 3 hours respectively, which again means that you need to have the 7 hours. But you also have to allow time for E to have been completed, and that may not have started at the same time that A began. In the event that one could not assemble a plan for the preparatory work to begin at connection point delta, dummy work is used in the form of a dotted arrow, and this is shown in the diagram. The time required for this work can be thought of as 0 hours. So any dummy work, this is very important, if you're going to use dummy work is thought of to take 0 hours. The earliest connection point time with regards to each connection point is the earliest time that one could start the work. In other words, no matter how rushed for time one is, one cannot start until after this particular point of time. And this is very important, it's the earliest time one can start the work. So that gives the particular point of time being the earliest connection point time. From that, one can calculate the shortest amount of time anticipated to complete the work for a specific project. You can see in this case that the first connection point is assigned the earliest time is 0 because that's when we're going to begin running our progress. In general, when building a framework for each connection point, one would write the earliest connection time above it. So that's been illustrated in a diagram. It's written as the 0 on top of the connection point. With regards to connection point alpha, that 0 represents 0 hours after the commencement of the work. Of course, that's when we start the stopwatch. That's when we begin our process. Since work B takes 4 hours, so we are looking at this leg of the diagram, the earliest connection point time beta could start, so the time that this connection point can start, the earliest is 4 hours. And this is quite simple to see because there are no other works leading up to it. It's only B. To get from alpha to beta, there's only work B. And work B takes 4 hours, so we write the number 4, which shows that it takes, if we say we're going to start the entire process at 0 o'clock, at noon, then we can say that the earliest time that connection point time beta could start would be at 4 o'clock, 4 hours later. Even though the same could be said about work A, at this stage the earliest connection point time for connection point gamma cannot be decided. It seems like it could be straightforward, but if you look at point gamma, there is also a connection from C, so we need to work out how we are going to choose our planning, and we'll talk about this in the next slide. For connection point gamma, the preparatory work concerned is A and C, as we can see and as we've discussed. And the completion time for each work would be calculated. With regards to work C, since connection beta can only be commenced at 4 o'clock, okay, you can only reach this point at 4 o'clock because you must have spent 4 hours doing B to get there. And work C itself takes 4 hours, so to get from alpha to beta to gamma, you must do works B and C to go through this corner. Then it takes 4 hours to do B, and it takes 4 hours to do C. So the total time it takes to complete work C would be 8 hours after you start the clock. So that means it will be 4 PM once you get to beta, and from beta to gamma it will take 4 more hours, so it will be 8 hours. So it will be 8 o'clock. With work A finishing at 7 o'clock, you can see A only takes 7 hours, but to get from B to C, alpha to beta to gamma, takes 8 hours. Keeping in mind what has been previously said, the preparatory work has to be completed before one can commence the work. So the earliest connection time from connection point gamma from start to finish would take 8 hours. It may seem like I'm repeating the same thing over again, but this is very important. Even though A takes 7 hours, you still have to wait that extra hour because you need to have completed B and C to get to point gamma. Applying the same logic, the shortest time it would take for this project from start to finish is 10 hours. And you can see this from the rest of the diagram. Hence, for this project, the earliest it could be finished is at 10 o'clock. So if you continue in the exact same way, the earliest time that you can finish is 10 hours after the commencement of alpha. In general, when building a framework for each connection point, one would write the latest connection time below it. So first of all, we see that we've got the earliest connection time at the top, but we're also going to write the latest connection time below it. The processing that is going to take place from now is referred to as backward processing, or sometimes known as backward computation. With regards to the last connection point epsilon, since the aim is to finish this particular project at 10 o'clock, the latest connection time is marked at 10. Since work F takes 1 hour, we can see this point here, the latest one could depart from connection point delta would be 9 o'clock. So we're going backwards now. We know that it takes the latest time that you can finish this project is 10, which means that if you go backwards, the latest time that you can finish and still arrive there at 10 o'clock, the latest time you can depart from connection point delta is 9 o'clock, because you subtract 1 from 10. Hence the latest connection point time from connection point delta is 9, even though the earliest is 8. Now this should be visible from the diagram. If we go back to connection point gamma, we can see that it takes 8 hours to be at gamma. Now if we're at gamma at 8 o'clock and it takes 2 hours to get to epsilon, but we're also at delta at the same time, and it only takes 1 hour, you can see there is a difference of 1 hour at this point. So this is what it's trying to calculate. So now if you have a look at the earliest time that we calculated at delta, and the earliest time that we calculated at gamma, we see work D takes 2 hours. As long as one departs from connection point gamma at 8 o'clock, it would be fine. However, one would have to consider too the work from connection point gamma to connection point delta. Considering the fact that one has to depart at connection point delta by 9 o'clock, and it is not caught by the dummy work that takes 0 hours. Remember that dummy works only takes no hours because it's not really a real work that you're doing. It's a virtual work, it's a dummy work. As long as one departs from connection point gamma by 9 o'clock, one will match the timing at connection point delta. By way of experiment, assuming that one is to depart from connection point gamma at 9 o'clock, with work D taking up 2 hours, which would effectively take us to connection point epsilon at 11 o'clock, that's 1 hour later, the project would have been delayed. Hence, at connection point gamma, one would have to leave by 8 o'clock in order to reach the desired destination by 10 o'clock. And so this is working backwards now. We've got to delta, now we're going backwards. We're going backwards from epsilon to gamma. Therefore, the latest connection point time at connection point gamma is 8. So that allows us to fill in the 8 below the earliest time, gamma. So in this case, you can see that gamma, the earliest time is the same as the latest time. You can see that in the red line, there is a path from start to finish, from alpha to epsilon. This is known as the critical path. When carrying out a project, enormous importance must be placed in management of the work concerning the critical path. The reason that it's called the critical path we will see in the next slide. In order to shorten the project work schedule, the work concerning the critical path must be shortened. However, the result of shortening it must lead to the formation of another critical path. The critical path has to be shortened. Critical paths are not necessarily restricted to only one, by the way. Regarding this particular question, it has been noted down clearly as to the fact that each work only has been shortened by 1 hour. By applying oneself to the answer group one by one can find the earliest connection point time. The result found is noted below. Moreover, based on the graph that sought the earliest connection point time, the places where there are changes are marked in blue. So let us go through all of the points, all of the answers that we had, and see which is the most suitable. First of all, option A, which was A, C, and E. If we have a look at A, C, and E, then if we shorten A by 1 hour, then we have, instead of 7 hours, it takes 6 hours to get to gamma. And we shorten C by 1 hour, then we take 3 hours. But now if we have a look at the path, to get from alpha to gamma, it takes 6 hours, so that's fine. But if you go from alpha to beta, which takes 4 hours, because we're not shortening B, it takes 4 hours, and to get from beta to gamma, it takes 3 hours. 4 plus 3 is 7. So even though A has been shortened by 1 hour, that makes absolutely no difference at all, because C takes 3 hours and B takes 4 hours, which means that you have to wait 7 hours at gamma. So it has to be 7 o'clock earliest at gamma. So it kind of feels like we've wasted shortening 1 hour, but we'll see what happens. Now if we also shorten E, it means that we can get from beta to delta in 2 hours. And through the use of the virtual or the dummy work, we can see that we'll be arriving there at 7 o'clock. Then from delta to epsilon it takes 1 hour. So we have 7 plus 1, which is 8. So it could be 8, but we also need D to finish. And D takes 2 hours, and 7 plus 2 gives 9. So even though it takes 8 hours to finish, you'd be finishing F by 8 o'clock. That doesn't mean anything because D still takes 2 hours after you've reached gamma, which means it would take 2 plus 7, which is 9 hours. So the earliest time that you can get there is 9 instead of 10, which is what we had before. And that means we've knocked off 1 unit of time. In this question, the question asks for days. We're talking in hours. It doesn't really make a difference. We're just talking about units of time. So we've saved 1 unit of time. The question asks to save 2 units of time, or 2 days, or 2 hours. So this can't be the correct answer. Let's move on to the next answer. If you have a look at answer B, we can see that it chooses to shorten A and D by 1 hour each. So let's see what that does. We start at alpha as usual at 0 o'clock, and if we shorten A by 1 hour, then we can finish A by 6 p.m. But if we go through again alpha, beta to gamma, you have 4 plus 4, which takes 8 hours. So even though you've finished A within 6 hours, you still have to wait until 8 o'clock until you say you've started at gamma. So at this point we're at 8 p.m. and we're at gamma. Now we don't shorten E, which means it takes another 3 hours to get to delta. And then D is being shortened by 1, which means that gamma and delta start at the same time, and D and F take the same amount of time, which means that we get there at 9. So we are at epsilon by 9. 9 again. So, okay, let's switch to days. We're at 9 days. Option C, we choose to shorten B, C, and E. Let's see what that does. Well, to get from alpha to gamma, First of all, we can go direct from alpha to gamma through A, and that takes 7. If we shorten both B and C, then we see that to get from alpha to beta takes 3, and then from beta to gamma takes another 3 more, which is 3 plus 3, which is 6. So even though you've shortened both B and C, that doesn't make a huge difference since A is taking 7. So whatever you do, you end up getting to gamma at 7. If we shorten E also, you can get from beta to delta within 2, and that means that you've still got to delta at 7 and gamma at 7 also. So you're at gamma and delta at the same time. You can see this is 7 and this is 7, that's the earliest times. Now if we look to get to epsilon now, process F only takes one day, 1 unit of time, but D takes 2 units of time, which means that the earliest you can finish is 7 plus 2, which is 9. So again we have 9 days. Let's have a look at D. If we choose to shorten both B and D, let's see what happens. First of all, we go from alpha to beta. So B has been shortened from 4 to 3 hours, or 3 days even, which means that we're here at beta at 3. And then to get from beta to gamma, it takes 4, so we are at gamma at 3 plus 4, which is 7 units of time. And that's exactly the same amount of time that A takes. This seems to look quite good because we are not wasting any time waiting. Nobody is waiting around for anything to happen. So this seems to be an efficient start. Now we say that we also shorten D. If D is shortened from 2 hours to 1, then that means that since to get from beta to delta takes 3, which means that we are at gamma and delta at the same time. We're at gamma and delta at 7. If D and F take the same amount of time, then we can finish simultaneously. So it takes 7 plus 1 to get to epsilon, which means that this time it takes 8 days. And then we have made a saving of 2 days, because originally we had 10 days on the schedule, so we saved 2 days. And this then is the correct answer. So the answer is D.